Hello student, in this video we are going to learn about example of Laplace transform and trigonometric formulas and Pascal triangles and binomial theorem. So, trigonometric formula is sin of a into cos b equal to half sin a plus b plus sin a minus b cos a into sin b equal to half sin a plus b minus sin a minus b cos a cos b equal to half cos a plus b plus cos a minus b sin a sin b equal to half cos a minus b minus cos a plus b. So these are the defactorization formula. Next is sin square x equal to 1 minus cos 2x upon 2, cos square x equal to 1 plus cos 2x upon 2, sin cube x equal to 1 by 4, 3 sin x minus sin 3x, cos cube x equal to 1 by 4, 3 cos x plus cos 3x, sin minus x equal to minus sin x, cos minus x cos x, sin hyperbolic function of sin x equal to e raised to x minus e raised to x upon 2, hyperbolic function of cos x equal to e raised to x plus e raised to minus x by 2, sin 2x equal to 2 sin x into cos. So these are the trigonometric formula. Whenever you solve the problem Laplace transform, even Fourier series, Fourier transform, complex variable, everywhere required all these trigonometric formula, because without this trigonometric formula we cannot solve the problems of Laplace, Fourier, or complex variables, or Laplace even Fourier transform. So these are the most important. We have to learn all this trigonometric formula. Now example of Laplace transform. Find the Laplace transform of Laplace of sine omega t plus alpha and Laplace of cos omega t plus alpha, Laplace of sin raised to pi t and Laplace of cos raised to pi t. So these few examples I have taken here. So first of all we are going to solve Laplace of sin omega t plus alpha. So here also directly we cannot apply the formula of Laplace. So try to bring in the linear form. So use the formula of sin a plus b, sin a cos b plus cos a sin b. So by this formula we can write down sin omega t cos alpha plus cos omega t sin alpha. Now here cos alpha is the constant term, so we can take outside Laplace of sin omega t plus here sin alpha is a constant, so we can take outside Laplace of cos omega t. So the formula of sin omega t is a upon s square plus a square. So instead of a we can write down the omega, so omega upon s square plus omega square and plus sin alpha write down as it is, and here use the formula of Laplace of cos a t equal to s upon s square plus a square. So here s upon s square, instead of we write down the omega square. Next example is a hyperbolic function of a sin raised to pi t, not hyperbolic function, this is the circular function. Laplace of a sin raised to pi t equal to, use the formula of circular function, sin x is e raised to minus x minus e raised to minus x upon 2y. So instead of x is even t, so e raised to it minus e raised to minus it upon 2i. Then 1 upon 2 raised to 5i is 1 upon 32i, I raised to 5 is I. Now this part we have to solve by the Pascal triangle or by binomial theorems. So here I have drawn some Pascal triangle 1 1 1 1 write down as it is, 1 plus 1 is 2 and 1. Then 1 write down as it is, 1 plus 2 is 3, 2 plus 1 is 3 and 1 write down as it is. Here 1 draw as it is, 3, 1 plus 3 is 4, 3, 3, 6, 3, 1 is 4, 1 write down as it is. Then 1 is 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, 1 write down as it is. So we can take up to here because the n is given 5. So here minus sign is given. So we can write down the alternate sign, minus plus like that. So e raised to 5it and the coefficients of is 5. So write down 5 e raised to 4it into e raised to minus it plus the coefficient is 10. So 10 e raised to 3it into e raised to minus 2it and 10 write down here minus 10 e raised to 2it into e raised to 3it minus 3it plus the next coefficient is 5. So 5 e raised to it into e raised to minus 4it and minus 1 write down here coefficient e raised to minus 5it. So these are the expansions of e raised to it minus e raised to minus it raised to 5 by the Pascal triangles. Now we have to collect the terms in the form of sin x. So here e raised to 5t and here is also minus e raised to 5it. Then if it's solved by the law of indices, so we'll get the e raised to 3it. Here also we'll solve by the law of indices. So e raised to minus 3 minus 5 is common. Next is the plus 10 is common and solve by the law of indices. Here e raised to it and here if you subtract we'll get the e raised to minus 20. So next required the in this circular form. So here required the upon 2i, here also required the 2i, here also required the 2i. So sin raised to 5t equal to 1 upon 60 Laplace of e raised to 5it minus e raised to 5t upon 2 minus 5 e raised to 3it minus 380 upon 2i plus 10 e raised to it minus e raised to it upon 2i. So this is the form of circular functions. So by the circular formula, this will be the sin phi t minus 5 sin 3t plus sin 3t. So this is the linear form. Now we have to apply the Laplace formula of each terms, providing the Laplace transform of each term. So 1 by 16 Laplace of 5t minus Laplace of sin 3t plus 10 Laplace of sin t. And then we have to use the formula of sin at is a upon s square plus a square. So instead of a is given here 5, so s square plus 5 square minus 5 into 3 upon s square plus 3 square. Here is the a is given 1, so 10 into 1 upon s square plus 1. So these are the complete solution of Laplace transform of sin raised to 5t. And these are the Pascal triangles, binomial theorem. So in binomial theorem, a plus b raised to n, nc0 a raised to n b raised to 0 plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b square plus ncn a0 b raised to n. So we can solve by the expansion of by binomial theorem also, and these are the Pascal triangles. I have already explained how to draw the Pascal triangles. Thanks for watching the videos.